next week lah. Okay, for the coding theory, actually the objective here, what we want to do is we are not going to write any code for this case. We will use the manual method where we will calculate using the matrix. Okay, so I will tell you first what is the coding that we are going to learn here. It is actually we will determine whether we can detect error or not, because every day we send message, right, from one to another using any devices. So in the middle of the sending all these messages, they will have some noises happen, or we call it as error happen. So when this happen, it will, like, the person who sent the message and the person who received the message, it will be in a different code already. Normally, when the message you read is already convert back to the word that you can understand. But halfway when we send the message, right, they are using the code to send the message. Okay, so the code that we use here is referring to the binary code lah. So it will be in the 0 and 1. So that is the process before you can read the message that you receive. So they will actually convert it to the computer languages and so on. Okay, so how do we know whether the error happened or not? Okay, so we have a few methods to determine or to detect the error here. And one of these is using we call it as a even parity check code. Okay, so one of the method. And as I say, the code that we send here, we will put it in the form of a binary code. So we will just write it as a 0 and 1. Hold on. So we will put it in the form of 0 and 1. That's why when you see the B here, this B is actually refer to the number of bits in the code that we have. So if we write it as a B2, means that this message now is 2 bits. Okay, and every time they will write like this, E, which means we will encode the message from the BM, which is n bits, to the BN. Now, normally the message that we receive, the number of bits will be more than the number of bits for the message we send. This is because the extra bit is normally for the checking purpose. Okay, so to detect the error and so on. So that's why the N here, which is the bits for the message that they receive, will be more than the number of bits that we send. So for example, if I send from B2, then the person who received B4, then the extra 2 bits here is actually for the error detection. Okay. So the error detection, if you use the even parity check code, it means that every time the correct code that we receive will be in the even number, the number of 1. We normally will refer to the 1 that we have in the code. What is the weight? What is even or odd? That are all referring to the number of 1. For example, if now the code is 1100, so the weight for this one, the weight we will refer to how many 1 inside this code. If here is 2, that means the weight is 2 lah. Okay, the weight normally they will put it as a modulus, then they will write it as 2. So for the even parity check code, if you have the code given, for example, for the word, let's say we have a B1, a B2, B3 until BM. This is the code in the binary form. So we will have EW, which is the encode the word from B1, B2, B3 to BM. Now we will have the extra bits at the back, BM plus 1, where the BM plus 1 Now, it will be equal to 0 if your weight just now is even. Meaning that if your B1 to BM are all the weight is even, then the last bit here will become 0 under the even parity check code. Because what we assume that under the even parity check code is all the code with the correct code will be in even number. That's why we call it as even parity check code. Though if you have the bits from B1 to BM, the number of 1 here is even, then the last bit, if it is a correct code, it will be 0. So that the weight will still be remain as even. Okay, but if your B1 to BM previously before the BM plus 1 is odd number, then the last bit of BM plus 1, it will be 1 if your weight for W is odd. Why it need to be 1? Because if the last bit is 1, combined with the odd number of 1 in front, then it will become even, right? So this even parity check code, the concept is we will have the code every time in even number if there is no error. Okay, so of course you will say, oh, what happened if my code now is 1100, but I received 1001. It is still with the even number, right? So that is the disadvantage for this lah. We cannot detect the error even the weight is still the same. Even error happen, but we cannot know. Okay, we can only know if the code is 1100, but it changed to 1000. In this case, it can change from the weight 2 to weight 1, right? So the even parity check code here will detect that there is an error happen here. Okay, so this BM plus 1 here is to tell you the last bit of the code, if it is follow the even parity check code, it will be 0 for the last bit if all the code before that is even, and the last bit will be 1 if the code before that from B1 to BM bit is odd number. So that odd plus the 1 at the back, it will become even. Okay, can understand what is this even parity check code or not? So the important thing is it needs to be in even number of 1. Yeah, so this is one of the way lah. Then this one I will tell you how many error we can detect later on. So the Hamming distance, if we want to find the code, what are the distance in between the codes, we can use the Hamming distance. So for example, the delta here is to show the distance in between the x and y. Let's say you have the codes of x and y. So to find the distance, we will use this exclusive OR method. For example, if now your code x is 10110001, and then your y code is 01110000. Okay, and you want to find what is the distance for these two codes, then you need to use the exclusive OR in between the x and y. So for exclusive OR, do you still remember if different 1 and 0, it is 1, right? If the same one, then it will be 0. Correct? Not? That is for exclusive OR. So here is 0, 0. Then you will get 0, 0. This one the same. We will get 0 also. And then this one also 0. This one is 1. This one is 1. So after you use the exclusive OR, you see how many 1 in your answer. That is the distance of the two codes here. Okay? So we will get the distance of xy in this case is 1, 2, 3. Right? The distance is 3 lah in this, because the bit different here, we have 3 bits different. Okay, and we have the theorem for the distance. Here are the theorem. Either xy or yx, they will get the same distance, and the distance will also more than or equal to 0. It cannot have a negative value. Then if two chords are the same, of course, their distance will be 0. Because if two chords are the same, then all the bits will be the same, right? Okay. And this one is the distance of xy. It will be less than or equal to xz plus zy. Okay. So these are the theorem for the distance. And to find the minimum distance, let's say we have a few chords like this. Let's say this is the encoding from 2 to 5. This 2, 5 here means we will encode from 2 bits. We send message 2 bits, and the person who receive will be 5 bits message. So we have extra 3 bits here. And they will write it like this. E00 equal to 00000 means that you have extra 3 bits at the back. So when you want to find the distance of the codes like this, what we need to do is we form a table. It will be easier. Instead of you go to find one by one, like 00 with 01, 00 with 10, 00 with 11, and so on. So you form a table like this, then every pair you can determine their distance. Okay, so we will use the exclusive OR also to find their distance. So for this one, when you find the distance, right, you will do it like the upper diagonal only. Here, you will get 0, 0, 0, 0, 0. You use exclusive OR. This one, you will get 0, 1, 1, 1, 0. This one, you will get 0, 0, 1, 1, 1. This one is 1, 1, 1, 1, 1, right? If you use the exclusive OR. Then, the answer for this cell, 1, 2, it will be the same with 2, 1. So 0, 0, 0, 0, 0, exclusive OR 0, 1, 1, 1, 0. It will be the same with 0, 1, 1, 1, 0 with 0, 0, 0, 0, 0, right? So that means this is symmetric actually. So we don't need to fill in every cell in the table. We only need to fill in either the upper triangle or lower triangle. Okay, either this part you fill in, this part here you fill in, or you can fill in this part. Okay, so it is up to you, upper or lower. You don't need to fill in for all. So don't waste the time to do all. Okay, so we will do the upper now. This C1, this one is C1. So of course you will get all 0 lah, because they are the same code, right? And then for C1 and C2 here, 0, 1, 1, 1, 0, exclusive all 0, 1, 1, 1, 0, 0, 1, 1, 1. So what do you get? 0, 1, 0, 0, 1, right? And for this one, 0, 1, 1, 1, 0 with 1, 1, 1, 1, 1, you will get 1, 0, 0, 0, 1. So after you do like this, then you can determine their distance. You see how many 1. So this one you have 3, 1. That means the distance is 3. This one also 3, 1. Distance also 3. This one you have 5, 1. Distance is 5. Here is 2, 1. Here also 2, 1. Right? And for C2 with C2, of course, you will get all the same 0. C2 with C3, so you will have 1, 1, 0, 0, 0. The distance is 2 here. And the last one, you will get 0, 0. Okay. And from here, every pair we have done already, we can see their distance. We have 3, 5, 2. So the minimum will be 2. Minimum distance will be a non-zero code. So the minimum distance from the table we get here will be equal to 2. Okay? Minimum distance is the non-zero code. Okay, now you have this one. Can understand a lot to find the minimum distance of the code. Okay. Do you have any question for this? No, okay. So this is the theorem. This is the theorem for the detection of the error. How many error we can detect is depends on the minimum distance. If your minimum distance is k, then you can detect k minus 1 error. If your minimum distance is 2, then you can detect up to 1 error. Okay. If your minimum distance is 3, then you can detect up to 2 errors and less. Either 2 error or less than 2 lah. Okay, so it cannot be more than the minimum distance we have. So the next one is the group code. Group code here, we will look at the subgroup. What is the meaning of group code? Actually, if let's say you have a few codes given to you, right? You want to determine whether it is a group code or not. So one of the way is we need to check whether all the codes given is the subgroup of the number of bits given or not. For example, if let's say this question, you have 4 codes here, right? And you want to see whether this 4 here is a group code or not. So in order to determine whether it is a group code or not, we need to check whether all these 4 codes are subgroup or not. Do you still remember what is subgroup in your chapter 3? Subgroup, you need to determine using the operator whether it is clause under the set given or not, right? And then the second one is you need to find the identity, whether it is belong to the set given or not. And the third one is you need to find the inverse, whether the inverse come from the set given or not. So for this group code here, if you want to decide whether this is a group code or not, then you need to check whether these 4 codes is the subgroup or not first. Okay, so this is what that means here. You need to check whether the set of all the code words form a subgroup of Bn or not. So I will show you how to determine it is a subgroup or not. Then only we can conclude it is a group code or not. Yeah. Look at the example 3 here. Let's say you have, because this one is come from here, this example, but from what we get just now, if I do the exclusive OR, I noticed that the answer I get for this is 01001. And this code is actually not from this form. Same also for the C2, if you exclusive OR with C1, C3 with C1, you see this answer is 10001, and it is also not of one of the code given here. Okay, so if you can show that any 2 of the code after you find the distance, the answer here is not from this 4, then it is not a subgroup anymore. Okay, because you remember, how do we show that it is clause under the set given in your chapter 3? We have shown that if I have 2 even integer, I add up even integer, I must get back even also, right? If I have 2 multiple of 3 integer, I add up any 2 integer with multiple of 3, the answer also must be multiple of 3. But what happened now is, I add up this C1 and C2, I get the answer is not from this form, not from the set given. Okay, so what we can do is, we will show any counter example, let's say C2 and C3. So what I get from C2 and C3 here, after I add it up, C2 exclusive OR with a C3, the answer now is 00111 exclusive OR with 11111. I get 11000, right? And this one is none of C2 C0, C1, C2, and C3. It is none of these. C0, C1, C2, C3. You know what is the C0, C1, C2, C3 just now? From the previous example, these are the code. Okay? So 11000 is not from here, one of them, right? Okay, so if it is none of these C0 to C3, that means we will say this C2 and C3, it is from the range just now. Okay, this is from the encoding function just now, right? The range means it is one of them lah, C2 and C3. But what happened after we find the distance, which is the exclusive of in between C2 and C3? We cannot get the answer from this range, which means it is not from this 4. Okay, this 11000 is not from this 4. So we will write it not belongs to the range given. Okay, so we can say that it is not, the range E is referred to these 4 codes here, C0 to C3, is not a subgroup. It is not a subgroup of B5. B5 means the 5 bits code. Okay, so if this happens, if it is not a subgroup of B5, then we will say this encoding function cannot be a group code. Encoding function E is not a group code. That's why I say if you want to decide whether it is a group code or not, the first thing you need to determine must be whether it is a subgroup or not. It is a group code. Okay, so you need to determine whether it is a subgroup or not. If you can get all the answer from any 2 codes given just now, if the answer you get here also from these 4 codes given, then you can say that it is a subgroup of the 5 bits code. If it is a subgroup, then your conclusion will be it is a group code already lah, the encoding function. Okay, but now it is not the case because one example, counter example, I get the code answer is not from this 4. That means it cannot be a subgroup already, right? So if it is not a subgroup, then it cannot be a group code lah for the encoding function just now. Okay. So this is one of the example to show that it is not a group code. Have you copied already? The person who absent, do you ask them whether they are remember we have replacement class or not? There are 5 persons absent here, except Chuan Yong. The rest of the 5, any friend of them, see whether they remember we have class. Done? Done, okay. So the next one, example here, we were referring to these 4 codes again, and we want to see whether this is a subgroup of B5 or not. So if the question asks you to show that it is a subgroup, then you show like just now, okay, we form a table, find the exclusive all of these 4 codes and see whether the answer belongs to these 4 or not. That is the first step. Then after that, you need to find the identity and inverse. So this is to show that it is a subgroup. If the question asks you it is a group code or not, you do the same also. you also need to determine whether it is a subgroup or not first. Then only conclude that if it is a subgroup, then conclude it is a group code. Okay, so this question and the question asking in the tutorial to determine whether it is a group code or not is the same. So you will use this method to do. Now we want to show that the code C here is a subgroup or not. So we need to form a table. I write the code first. The 5 codes here, C0, C1, C2, and then C3. Okay, same also for the row here. 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, and 1, 1, 1, 1, 1. So we form a table. This is exclusive of. Then we will write all the answer inside the table here. Same like just now. Okay, so we do the upper triangle, we'll do. This is 5, 0. This is 2, 0. 3, 0. This one 2, 0. This one 1, 1, 1, 1, 1. And then this part will be all 0. Then this one 0, 1, 1. So we have 1, 1, 1, 1, 1. Right? And this one you have 1, 1, 0, 0, 1, 1. And for this will be all 0. And this one 1, 0, 0, 1, 1 with 1, 1, 1, 1, 1. So we will have 0, 1, 1, 0, 0. And here is 0, 0, 0, 0, 0. Okay. Now we do the upper triangle is enough. So if you want to check whether all the codes belongs to this or not, you need to label first. This is your C0, C1. If the question already given, then you follow. If not, you need to label yourself. This is C0, C1, C2, C3. So from the answer inside the table here at the side, you can write this is C1. And then this is C2. This is C3. This one also C3. This one is C2. This one is C1. So you can see that all the code, after you find the distance, right, they are from C0 to C3, right? So we will write the first condition to show it is a subgroup. We will write it as Ci, because we have C0 to C3, then we put I and J. I refer to the row and J refer to the column. Ci and Cj are from the code C given. And what happened after we have exclusive or Ci with Cj? Any code of them, it will belongs to C also, right? Okay, no matter it is C0 with C1 or C1 with C2 or C2 with C3. So here, you need to define what is your I and J. So your I will start from 0, 1, 2, 3. And your J is referring to the column 0, 1, 2, 3 also. Okay, so you no need to write for all one by one. You no need to write C0, C1, C0, C2, C0, C3, and so on. Okay, you only need to put it in a general form like this to show that it is all from the C0 to C3. So this is the first condition to show a subgroup. Now the second one is identity. Can you tell me what is the identity for this case? Who can tell me identity for this?